Hello all. Today we will discuss about initial condition of inductor. Let we have a circuit diagram. This is a voltage source V connected to a switch. This is switch and this is connected to a inductor L. This is voltage and this is a switch at t is equal to 0. This current I will be flowing through the circuit. At t is equal to 0, this switch is closed and it reaches from A point to B. Then we know that phi is directly proportional to I. Also we know that di, rate of change of current, is directly proportional to rate of change of flux. That means inductor is definitely dealing with the rate of change of current, and if there is a rate of change of current, that means it has a rate of change of flux. Until and unless if we have a rate of change of flux, then definitely we have a induced voltage across the inductor, which is given by VL directly proportional to di by dt, or we can write VL is equal to L di divided by dt, or this VL is nothing but L d phi divided by dt. Until unless this inductor will have the value of flux, this value of flux will be expanding. The amount by which it is expanding, the same amount it will oppose the current I. So we can conclude that inductor opposes the rate of change of current. So we can write the equation as VL L di by dt. Let we assume another case in which at t is equal to 0, a circulating current I is flowing in the circuit. This is the circulating current which is flowing in the circuit. Since this I is flowing in the circuit, we'll have a dt tends to 0 at t is equal to 0. Then di divided by dt, this dt tends to 0 will give an infinite value, or this voltage across the inductor, which is given by L di by dt, this dt tends to 0, hence voltage across inductor is infinity. Practically, this value of inductor voltage is not possible. So we can conclude that inductor opposes the instantaneous change of current. Okay. However, at t is equal to 0 minus, we have a current IL 0 minus is equal to 0. That means your inductor is behaving as a open circuit. If IL 0 minus is equal to 0, then IL 0 plus is also equal to 0. Why? This is the condition just before the switching. This is the condition just after the switching. So before the switching and after the switching, we'll have this expansion of field or contraction of field. This expansion and this contraction will opposes the main current. That means inductor will oppose the instantaneous rate of change of current, which makes the inductor current as 0. Hence, your inductor will be operated as open circuit during this condition. So at t is equal to 0 minus, you have IL 0 minus as 0, and at t is equal to 0 plus, that is just after the switching, you have a value IL 0 plus is equal to 0. So we can conclude IL 0 minus, that is equal to IL 0 plus. This is a very strong logic for the inductor. So we identified that at this condition your inductor will be operated as open circuit, because at t is equal to 0 minus and t is equal to 0 plus, your current across the inductor is 0. In other words, let we can define the same as, let we have a value of current across the inductor as 1 by L minus infinity to t VLT multiplied by dt. This is equation number 1. We can write the same equation as ILT, that is equal to 1 by L minus infinity to 0 VLT dt plus 1 by L 0 to t VLT dt. This is equation number 2. Here, this is the value which we have IL at 0 minus, and we know that this is initial current across inductor flowing at IL 0 minus. So we can write the same equation as ILT, that is equal to IL, that is equal to IL 0 minus plus 1 by L 0 to t VLT dt. This is equation number 3. If switch is changed, then the value of inductor at t 0 plus, suppose at this point your switch is changed, so we can say at t 0 plus we have IL 0 plus, that is equal to IL 0 minus plus 1 by L 0 to 0 plus VLT dt. Why we have written 0 plus? Because we have considered at t is equal to 0 plus. So put all the value of t at 0 plus. So we can have an equation like this, and this is nothing but this is equation number 4. Here, this is the integration which has from just switching to just after the switching, which is at most and almost equal. So integration of same limits is always equal to 0. And when it is 0, it is during the transient. When it is 0, it is during the transient. Why? Because your switch changes from just switching to just after the switching. Okay, so we can write the equation as IL 0 plus that is equal to IL 0 minus. Already we have discussed that IL 0 minus IL 0 plus, at this particular point your L will be open circuited. So we can conclude that your inductor will be open circuited at these points. Let us suppose we have to consider our two conditions, and the condition is nothing but if there is no initial current in the inductor. This is inductor and there is no initial current, at this particular time your inductor will behave as open circuit. Why? Because IL 0 minus is equal to 0. So IL 0 plus is also equal to 0. That means at this particular time your inductor will behave as open circuit. Let us consider case number 2. In this, the inductor has some initial current, and this initial current is nothing but this is I. So at this particular point your inductor will behave as short circuited or behaving as a current source. This is current source I. Why? Because IL 0 minus is equal to I. This is the condition, this is initial condition. So this is the condition before switching, and before switching we have an initial value of current I. So IL 0 minus is equal to I, hence IL 0 plus is also equal to what? I. So at this particular point, since we are getting a value of current, hence your inductor will behave as a short circuit or behaving as a current source. This is the important logic which we have to understand. If we have no initial current, then your inductor will be behaving as open circuit. Initial current means before switching, just before switching we have a value as 0. So after switching we will have a value of 0 from this relation. Let we have an initial current I. From where it comes? Suppose an inductor which is connected to a source which is already energized and it is suddenly removed from the source. So at that point your circuit will have an initial current I. So at this particular point it is just acting as before switching. So just before switching we have a value of I. So after switching also will have a value of I, or your inductor will behave as a short circuit and this will behave as a current source. So this particular point is very important. Let we have to find the value of inductor, and what value we have to find? We have to find the final value of inductor. Let we have to find the final value of inductor. We know that VLT that is equal to L di divided by dt. Since your inductor is connected for a long time in the circuit, hence this dt tends to infinity, and we know that VLT that is equal to L di of t. This dt tends to infinity, hence this is equal to 0. So at this particular point, your inductor will behave as a short circuit. So at t is equal to infinity, you have a final value of inductor, and this final value is nothing but VLT is equal to 0, and your inductor will behave as short circuit. Let we elaborate the same expression in another way. Suppose we have a voltage source, this is a voltage source V, and this is a switch. This switch is, this is a switch. This is inductor L, and this is a switch which is connected to a point A. At this particular point, since your inductor is connected so long with the source and it has a value I0 flowing through the inductor because it already reaches to its steady state. The transient state will only be there till your rate of change of flux will occur across inductor. This I0 we get is after the steady state. This circuit is already having a steady state value because the inductor is connected to a source for so long. Let us say a current I0 is flowing through the inductor at t is equal to 0. This voltage source is removed from the circuit. Now your switch is removed the voltage source from the circuit. We know that your inductor opposes the instantaneous change of current. So at t is equal to 0 minus, you have initial current as I0. How we can get? This is the steady state value which we get when your inductor is connected so long to the voltage. But when your voltage will be removed, then this current will be acting as an initial current to the circuit. So at t is equal to 0 minus, you have a value I0. So at t is equal to 0 minus, just before the switching, we have a value I0. Hence the same value we will have at just after the switching. Therefore IL 0 plus is equal to IL 0 minus is equal to I0. We know that VL is equal to LdI by dt. Once transients get over, there will be no change in the current. So at t is equal to infinity, VL is equal to L di by dt. At this particular point, your transition is over, hence no transition will be there and your circuit is reaches to a steady state. Hence this t tends to infinity will gives a value as 0. So voltage across inductor at final condition when t tends to infinity will be equal to 0. Hence we can say at this particular point, at final condition, your inductor will behave as short circuit. Let we conclude the session with few remarks. At t is equal to 0, your switch position will be just at t is equal to 0 minus, it will be just before switching, and your inductor will be acted as open circuit. At t is equal to 0, this is just switching, and still we have still a rate of change of current which is opposed by the inductor. Hence, there will be no value, so we can say your inductor will behaving as open circuit. We will have a value of voltage VL at this point. At t is equal to 0, again we have a change of current due to a change of flux, and at this particular point your voltage will be induced, so voltage across inductor will we have. So at this point your inductor will behave as open circuit, since there is no current flowing through the inductor which is opposed by the inductor, and this inductor opposes the rate of change of current, and this rate of change of current is because of rate of change of flux will definitely produce a voltage across the inductor. So at t is equal to 0 plus, again this is just after the switching, your circuit will again behave as open circuit, because at this point also you have d phi by dt which is directly proportional to di by dt, which give rise to a voltage, and this voltage is induced in the inductor. At t is equal to infinity, then your switch position is maximum time in the circuit after switching will have a short circuit. This inductor will behave as a short circuit because dt tends to infinity and di by dt will become 0. Hence VL, that is equal to L di by dt, is equal to 0. So VL is equal to 0. Let us suppose we have an initial condition at t is equal to 0 minus IL0 minus will have initial current I0. So IL0 plus will also have initial current I0, from which relation IL0 minus is equal to IL0 plus. So at this particular point your inductor will behave as a current source. So at t is equal to infinity, we have a voltage which is equal to 0, and rest of the time we will have a voltage VL is equal to L di by dt. I hope you got the point. Thank you very much.